Hello, all of us have heard the term operating system while talking about computers. Today, let us understand what operating system is and the role of operating system in the functioning of computer. A computer cannot do anything by itself. We need to give instructions to it to do a desired job. Thus, it is essential to specify a sequence of instructions that a computer must perform to solve a problem. Such a sequence of instructions, which is written in a language understood by a computer, is called a computer program. A program controls a computer's processing activity. System software is a set of one or more programs designed to control the operation of a computer. An operating system is system software that manages computer hardware and software resources and provides common services for computer programs. The operating system provides an environment in which a user can execute programs in a convenient and efficient manner. An operating system acts as an intermediary between the user of a computer and the computer hardware. An operating system is a resource allocator. A computer system has many resources such as CPU, that is the central processing unit, memory space, file storage space, input output devices and so on that may be required to solve a problem. The operating system acts as the manager of these resources. There are numerous and possibly conflicting requests for resources. The operating system must decide how to allocate them to specific programs and users so that it can operate the computer system efficiently. Like a manager of a company, an operating system is responsible for the smooth and efficient operation of the entire computer system. The kernel is the most important part of the operating system. It consists of the very essential routines which are required very often and hence are required to be kept all the time in memory. This is the innermost layer of the operating system. It controls the actual hardware. It is the heart of the operating system. The operating system must ensure correct operation of the computer system. To prevent user programs from interfering with the proper operation of the system, the hardware has two modes, user mode and kernel mode. Various instructions such as input output instructions and halt instructions are privileged and can be executed only in kernel mode. A computer system consists of hardware, software and data. The operating system provides the means for proper use of these resources in the operation of the computer system. The primary aim of mainframe operating system is to optimize the utilization of hardware. Operating systems in personal computers, commonly known as PCs, support complex games, business applications and everything in between. Operating systems for handheld computers are designed so as to provide an environment in which a user can easily interface with the computer for the execution of programs. Thus, it can be said that some operating systems are designed to be efficient, some are designed to be convenient, while some are a combination of the two. An operating system provides services to both the users and to the programs. It provides programs and environment to execute. It provides users the services to execute the programs in a convenient manner. A few common services provided by an operating system are program execution. It loads a program into memory, handles program's execution. Next one, input output operations. Operating system provides the access to the required input output device when required. Next service, file system manipulation. The operating system gives the permission to the program for operation on file. Permission varies from read only, read write, denied and so on. Operating system provides an interface to the user to create or delete files. Operating system provides an interface to the user to create or delete directories. Next one, communication. One of the tasks of an operating system with respect to communication is to transfer data between two processes. Both the processes can be on one computer or on different computers, but are connected through a computer network. Next service is error detection. The operating system constantly checks for possible errors. The operating system takes an appropriate action to ensure correct and consistent computing. Next service is resource allocation. The operating system manages all kinds of resources. Next one is protection. The operating system ensures that all access to system resources is controlled. The operating system ensures that external input output devices are protected from invalid access attempts. The operating system provides authentication features for each user by means of passwords. Let us now understand functions of operating system. First one, process management. A program does nothing unless its instructions are executed by a CPU, that is the central processing unit. A program in execution is a process. A word processing program being run by an individual user on a PC is a process. A system task such as sending output to a printer can also be a process. A process is the unit of work in a system. Such a system consists of collection of processes, some of which are operating system processes, those that execute system code, and the rest of which are user processes, those that execute user code. The operating system is responsible in the functioning of these activities in connection with process management: scheduling processes on the CPU, creating and deleting both user and system processes, providing mechanisms for process synchronization, providing mechanism for process communication, suspending and resuming processes. Next function, memory management. The main memory is generally the only large storage device that the CPU is able to address and access directly. For example, for the CPU to process data from disk, those data must first be transferred to main memory by CPU generated input output calls. Instructions must be in memory for the CPU to execute them. To improve both the utilization of the CPU and the speed of the computer's response to its users, general purpose computers must keep several programs in memory. Due to this, a need for memory management is created. The operating system is responsible for the functioning of these activities in connection with memory management. Keeping track of which parts of memory are currently being used and by whom. Allocating and deallocating memory space as needed. Deciding which processes and data to move into and out of memory. Next function is input output management. Operating system coordinates and assigns different input output devices while one or more programs are being executed. Next function, storage management. The operating system maps files onto physical media and accesses these files via the storage devices. The operating system is responsible for these activities in connection with file management, creating and deleting files, creating and deleting directories to organize files, mapping files onto secondary storage, backing up files on storage media. Next one, mass storage management. Main memory is too small to accommodate all data, programs, and the data that it holds are lost when power is lost. Hence, computer system must provide secondary storage to back up main memory. Most of the programs are stored on a disk until loaded into memory, and the disk is then used as both the source and destination of their processing. Hence, the proper management of disk storage is of central importance to a computer system. The operating system is responsible for these activities in connection with disk management. Free space management. Since disk space is limited, we need to reuse the space from deleted files for new files if possible. To keep track of free disk space, the system maintains a free space list. The free space list records all free disk blocks, those not allocated to some file or directory. Storage allocation. An important issue for an operating system while creating files is how to allocate space to these files so that space is effectively utilized and files can be quickly accessed. This is done by using some allocation methods. Disk scheduling. For a multiprogramming system with many processes, the disk queue may often have several pending disk input-output requests. Thus, when one request is completed, the operating system chooses which pending request to service next. The operating system makes choice by using any one of the several disk scheduling algorithms. Next function, establishment of data security and integrity. Operating system keeps different programs and data in such a manner that they do not interfere with each other. It protects itself from being changed or damaged by any user. Now, let us know about the different types of operating system. First one, batch operating system. The users of a batch operating system do not interact with the computer directly. Each user prepares his job on an offline device like punch cards and submits it to the computer operator. To speed up processing, jobs with similar needs are batched together and run as a group. The programmers leave their programs with the operator, and the operator then sorts the programs with similar requirements into batches. The problems with batch systems are lack of interaction between the user and the job. CPU is often idle because the speed of the mechanical input-output devices is slower than the CPU. Difficult to provide desired priority. Next type is multiprogramming operating system. One of the most important aspects of the operating system is the ability to multiprogram. Multiprogramming increases CPU utilization by organizing jobs so that the CPU always has one to execute. The operating system keeps several jobs in memory simultaneously. Since main memory is too small to accommodate all jobs, the jobs are kept initially on the disk in the job pool. The operating system picks and begins to execute one of the jobs in memory. Eventually, the job may have to wait for some task, for example, an input-output operation to complete. In a non-multiprogramming system, the CPU would sit idle. In a multiprogrammed system, the operating system simply switches to and executes another job. When that job needs to wait, the CPU is switched to another job and so on. Eventually, the first job finishes waiting and gets the CPU back. As long as at least one job needs to execute, the CPU is never idle. Third type is time sharing operating systems. Multiprogrammed systems provide an environment in which the various system resources such as CPU, memory and peripheral devices are utilized effectively. But there is no user interaction with the computer system. Time sharing or multitasking is a logical extension of multiprogramming. A time shared operating system allows many users located at various terminals to share the computer simultaneously. Processor's time, which is shared among multiple users simultaneously, is termed as time sharing. In time sharing systems, the CPU executes multiple jobs by switching among them. The switches occur so frequently that the users can interact with each program while it is running. As the system switches rapidly from one user to the next, each user is given the impression that the entire computer system is dedicated to his use, even though it is being shared among many users. Time sharing requires an interactive computer system, which provides direct communication between the user and the system. Next type is distributed operating system. A distributed operating system is the software over a collection of independent, network, communicating and physically separate computational nodes. Distributed system makes the whole network transparent to the users. The database, files, printers and other resources are shared among a number of users actually working on different machines, but who are not necessarily aware of such sharing. Distributed systems allow parallelism, that is, they find out whether a program can be segmented into different tasks, which can then be run simultaneously on different machines. The operating system must hide the hardware differences which exist in different computers connected to each other. Distributed systems have to provide for high level of fault tolerance, so that if one computer is down, the operating system could schedule tasks on the other computers. The next type is network operating system. A network operating system runs on a server and provides the server the capability to manage data, users, groups, security, applications and other networking functions. In network operating system, the users are aware that there are several computers connected to each other via a network. They also know that there are various databases and files on one or more disks and also the addresses where they reside. There can be one or more printers shared by various users logged on to different computers. Examples of network operating system include Microsoft Windows Server 2008, Unix, Linux, Novel NetWare. Another type of operating system is real-time operating system. Real-time systems are used when there are rigid time requirements on the operation of a processor or the flow of data, and real-time systems can be used as a control device in a dedicated application. A real-time operating system must have well-defined fixed time constraints, otherwise the system will fail. For example, scientific experiments, medical imaging systems, industrial control systems, weapon systems, robots. air traffic control systems, etc. Examples of operating systems are Microsoft Windows. Microsoft Windows is a group of operating systems manufactured by Microsoft. Windows is available in 32 and 64-bit versions and offers a graphical user interface known as GUI, multitasking functionalities and support for several peripheral devices. Windows operating systems constitute client as well as server versions. The classic Mac OS is Apple's operating system used in Macintosh computers prior to the release of Mac OS X. Mac OS X is Apple's current OS series. Now, let us see what open source operating system is. Open source operating systems are those made available in source code format rather than compiled binary code. Linux is an example of open source operating system, while Microsoft Windows is an example of the opposite closed source approach. The benefits of open source systems are: programmers can contribute to the code by helping to debug it, analyze it, provide support and suggest changes. Open source code is more secure than closed source code because many more eyes are viewing the code. If open source code has bugs, bugs tend to be found and fixed faster owing to the number of people using and viewing the code. Linux is an example of open source operating system. In 1991, a student in Finland, Linus Torvalds, released an elementary Unix-like kernel. He did this by using the GNU compilers and tools and invited contributions worldwide. The advent and the growing usage of internet meant that any person interested in the work could download the source code, change or modify it and then forward these changes to Torvalds. The Linux operating system released updates once every week and thus it grew rapidly, being equipped and enhanced with thousands of programmers. Solaris is the name of the commercial Unix based operating system of Sun Microsystems. Sun Microsystems open sourced some of the Solaris code in the year 2005. The company has since then added much more to that open source code base. iOS, formerly known as iPhone OS, is a mobile operating system created and developed by Apple Inc. It has been created exclusively for its hardware. This operating system currently powers many of the company's mobile devices, which also include the iPhone, iPad and iPod Touch. After Android, it is the second most popular mobile operating system worldwide by sales. The user interface of iOS is based upon direct manipulation using multi-touch gestures. Interface control elements consist of switches, sliders and buttons. Interaction with the OS is possible. This includes gestures such as tap, swipe, pinch and reverse pinch. All these gestures have already been defined within the context of the iOS operating system and its multi-touch interface. Major versions of iOS are released on an annual basis. Android is a mobile operating system developed by Google. It is based on the Linux kernel and has been designed primarily for touchscreen mobile devices such as smartphones and also tablets. Android's user interface is also mainly based on direct manipulation with the use of touch gestures. These gestures are somewhat similar to real world actions such as tapping, swiping and pinching to manipulate on-screen objects. It also has a virtual keyboard for text input. Not just for touchscreen devices, Google has also further developed Android TV for televisions, Android Auto for cars and Android Wear for wristwatches. Each comes with a specialized user interface for the particular work it performs. Variants of Android are also in use in notebooks, digital cameras and other electronics. To summarize, the fundamental goal of computer systems is to execute user programs and to make solving users' problems easier. Computer hardware is constructed towards this goal. Since bare hardware alone is not particularly easy to use, application programs are developed. These programs require certain common operations such as those controlling the input-output devices. The common functions of controlling and allocating resources are then brought together into the software, the operating system. An operating system is an integrated set of programs that is used to manage the various resources and overall operations of a computer system. A process or job is the fundamental unit of work in an operating system. One of the functions of the operating system is process management, which includes creating and deleting processes and providing mechanisms for processes to communicate and synchronize with each other. An operating system manages memory by keeping track of what parts of memory are being used and by whom. The operating system is also responsible for dynamically allocating and freeing memory space. Storage space is also managed by the operating system. Operating system is concerned with the protection and security of the operating system itself and users. A recent and very popular mobile operating system developed by Google is Android. I hope that you have understood the role of operating system in the functioning of computer. Thank you.